Hey everyone, welcome back to our next class of Catalyst concepts. Today we are going to look a little bit further into total internal reflection. So until now we have seen how total internal reflection works. We did some sums. We also looked at two activities. Today we'll look at where do we see total internal reflection in real life. Okay. Now, the biggest place that total internal reflection is observable is in a phenomena that we might have seen, all of us might have seen. It's called as a mirage. A mirage is basically on a very hot day. If you ever look at the road, it will look a little bit watery. It looks like there is water, and you can all probably also see like a reflection of what's on top of the road. If you ever noticed it, especially on long stretches of the road, then yes, that is called as a mirage. It typically occurs only on hot days or in hot places. Easy depiction for you would be cartoons. Remember, in some cartoons, they'll show there in the desert, and then they'll see as if there is water, but then actually there is no water. It just appears like that. So that is one very common example of a mirage, and it happens due to total internal reflection. Let's try to figure out how this mirage exactly happens. Okay, so assume that this is a road, and say you're standing over here as an observer, right? And say that maybe there is like a house or some object over here. Let's just call it a house, right? Now, what happens typically, that light comes from the sun, right? It's up in the sky. So, this light travels always in a straight line. So, it would come towards you or towards the house, towards in every direction. Light just goes out in straight lines, which is why you're able to see. That is how light and vision works. But what happens in a mirage is you'll not be able to see things very clearly. The reason for that being the heat. Now, how this heat works for us is assume you're on the same road and the sun is shining bright. Now, when it is hot, what happens to things? They get heated up, right? It becomes hot. The air also becomes hot. Now, you know that roads are black and they hold a lot of heat. So typically what happens is on this all of these roads, they gather heat, and the air that is just above the road becomes very hot. Okay, air is hotter close to the road, close to the surface, because they're absorbing more heat. And air that is up there on the top, the air will be slightly colder. Okay, there's a constant convection of air getting hot here going up and colder air coming down, but always over here is when the air is hotter and on the top the air is colder. Now, when air is hotter, it becomes less dense. Or, in other words, can we say it's a rarer medium? Okay. The colder air is more dense. So we call it the denser medium. Okay. Now, within the same medium, that is air, we have two different densities now. The upper layer is more dense, it's the denser, and the lower layer has become rarer. So in the same situation as we were before, if there is a house and the sun and there's a person standing there somewhere over, let me just draw him here. Now you will see that this person is somewhere at the boundary of two different media, or one dense and one rare medium. And we know that whenever light is going through the dense medium, that is where total internal reflection will happen. So this would be the original case, number one, on a normal day. Number two, or the second case, would be more like this, wherein the sun shining, and because of this density difference, what happens to the light is, the light that travels all the way here till the road is going to get reflected. Total internal reflection. Within this medium itself, the light is going to bend and go towards the observer. Okay. It does not go straight down anymore. Some part of the light is going to bend and some also goes down. But majorly the difference is because of the light that is bending. Now imagine there's another light that is going, touching the house and going through, but that also bends and goes to the observer. Now what it will look like is as if there is an image over here. It looks like there is a mirror because of the light bending and reflecting. That is why whatever this light is falling on, be it the house or anything else, you'll be able to see its image on the road. The image of the house would be visible on the road. It will look as if it's a mirror. It won't be exactly on the road also, just somewhere above it. So this is why the road will look kind of like water, because it's almost behaving like a mirror. This is how a mirage works. This is how mirages will work. A very common example. Okay. Now that we have seen what mirages are, and that is just an example of total internal reflection we see in daily life, let us look at what can total internal reflection be used for in our daily lives. There are certain applications that are used all the time. Okay, one simple example would be in diamonds. If you ever seen a diamond either in real or in movies or videos, you'll see that a diamond is very sparkly, right? It keeps sparkling always. There's like, it's like glittering and glimmering. The reason for that is total internal reflection. Now what happens is the diamonds are cut in such a way that light can enter from so many different sides. Okay, and because of that, the critical angle for the material is also very low. Okay, critical angle is low. It means most of the light that goes inside the diamond is going to get internally reflected. So basically there is a lot of total internal reflection that happens. That light that just keeps bouncing around inside of the diamond, which is what makes this diamond look like it is glittering. Okay, so that's not exactly a shine, it's more of a glimmer. It's more of just light bouncing around inside of the diamond. Okay, so that's the reason for diamonds to shine. Okay, another simple use for this is in optical fiber. Optical fibers. You might have heard the word before. If you haven't, also it's fine. Nowadays, most of our internet communications and some telephonic lines, they are all optical fiber cables. Okay, they are also called as OFCs. Okay, what this OFC is nothing but inside of the wire is a very thin strand inside which light is going to travel. Okay, they send light inside of this cable, and that light carries the information that we're supposed to, and that light just keeps bouncing around inside and goes to very long distances. Okay. The reason optical fiber is used in communication is, one, light is the fastest thing in the universe, so the speed of it is going to be very fast. Okay. Another thing is, it is also better in terms of quality, because you're talking about data that is going. Light does not lose data. The older ways that we used to use communication in copper wires and all, those have a tendency to lose data, but light does not lose a lot of data. So these two are the major reasons why optical fiber is used for communication. So it will be used in our internet cables, in our there'll be like big cables in the ocean also that carry phone lines. A lot of places where optical fibers are used. It is also used in medicine. So you must have heard of this procedure called laparoscopy or endoscopy. So basically, this is a procedure where the doctors are going to send a wire inside of our body to see what is happening inside, because light cannot enter inside our body, right? Because we are opaque. So what these procedures do is, through that optical fiber, they send light inside our bodies. So once the light is inside our body, there's also a camera attached to this laparoscope. So that camera will capture the light, will be able to see, because of the light inside, about what is happening exactly inside the body. And there's also another cable that will allow the light to go out of the body. Okay. So in medicine, in internally, to see what's happening in the body, optical fibers are also super helpful. All right. So that's the two major uses that we have for uh, total internal reflection. So apart from the phenomena, these are the uses. That's about it for today, today's class. So tomorrow we are going to continue with the next topic, and that's it for today. I will see you tomorrow. Thank you very much.